Hello, everyone, and welcome back. So we're looking at exponential and logarithmic functions, and in this video, we want to talk about solving exponential equations with a common base. So let's have a look at that topic over here. So solving exponential equations with a common base. Now, here is some of this. Here are kind of what we want to keep in mind. So first, an exponential equation is an equation with where the variable is in the exponent. So basically, if I had something like this, like 3 to the power of x is equal to 9 to the power of 20, I don't know, right? So you have an equation where your variable is actually in the exponent. That's an exponential equation, okay? So here's the procedure that we're kind of highlighted. So over here, it says use the following procedure yet to solve an equation where the variable is in the exponent. So basically it says, when you're solving for an equation, when you're solving an equation, you're trying to solve for the variable. You're trying to say, oh, the variable is whatever, 5 or something. You're trying to say, what is the variable? And so it says, use these steps, write each side of the equation in the same base. So if I were to take this example, I'm going to change this number, it's too big, but let's say it was like 4. Okay. Now over here, what we can see is I could write this in the same base, right? So 3 to the power of x is equal to 9 to the power of 4. Well, I could rewrite this as 3 to the power of x. I can't change the 3 to become a 9, but I could change the 9 to become a 3. I could always go down. And so I could rewrite this 9 as 3 to the power of 2, right? That's 9. And it was 9 to the power of 4. And then I can do power of a power. So this is 3 to the power of 8. And this is 3 to the power of x. Okay, so now that we've written it as each side has that common base, it says if necessary, use exponent laws so that each side of the equation contains only one base. So just like we did over here, we have one base. We didn't need to use really exponent laws, but yeah, we did over here power of a power to kind of simplify that. And then equate the exponents on each side of the equation, determine the value of the variable. Okay, so that last step is kind of not really simple to just go like, oh, to just determine it. But basically what it's saying is if I'm raising 3 to the power of something and it's equal to 3 to the power of something, well, that something has to be the same, right? Because it's saying 3 to the power of something, 3 will be multiplied by itself however many times to equal to 3 will be multiplied by itself how many times, right? So basically over here, that how many times, that means the exponents have to be exactly the same. So once I've gotten that common base, I just go, oh, set the exponents equal. And sometimes you'll have a little bit more complicated situations, but in this case, really, it's just that simple is that, oh, these two exponents are the same. Let me show you another example real quick before we end this video for something similar to this. So let's say I had 3 to the power of x is equal to 27 square root of 3. All right, now we're looking at this, we're like, oh, okay, that's not really nice, but we could rewrite this as something to the power of, we could rewrite this as something having the common base. Over here, we can see that I can't really change much about this 3, but the other side, usually you want to work on the complicated side. The other side, could write it as 3 to the power of something. So over here, this is 3 to the power of x is equal to 3 to the power of what gives me 27? So I know 3 to the power of 2 gives me 9. 3 to the power of 3 gives me 27. And so over here, I'll go 3 to the power of 3 instead of 27 multiplied by, now remember, whenever I have a root or a radical, that came from an exponent that's a quotient or an exponent that's a fraction. So over here, I can rewrite this as 3 to the power of, this is the power, this is the index, and so I go 1 over 2. Okay, I take this, I keep it with the 3 on top, and this goes on the bottom. And so over here, this is 3 to the power of 1 over 2. Okay, now they did say, we did say that sometimes you're going to need to use some exponent laws. In this case, I can see that I'm multiplying two exponents of the same, two powers of the same base. And so I can add their exponents. So I'm going to go, oh, okay, well, that's going to equal to 3 to the power of 3 plus a half is just going to be 7 halves. All right. And so over here, I'm going to have 7/2, and this side is 3 to the power of x. Now we can see that if I'm saying 3 to the power of something is going to equal 3 to the power of something, well, these two somethings have to be equal. So x is equal to 7/2. Okay. All right, so that's pretty much it for this section, everyone. You just have to make sure that you follow some steps, try and get that common base. And as soon as you have one base on each side and it's the same one, then you can just say their exponents are equal. Okay. All right, everyone. So that's it for this question. Oh, sorry, that's it for this section. I'll see you in the next section. Bye.